Hey guys, welcome back to 5 Academy. It's Shahir. So today we're going to be going through a 60-minute, 60-question ACT math exam. Obviously, as you can see, it's going to take a little longer than 60 minutes, so bear that in mind because I'm going to break down all these problems and kind of show you the skill behind each and every one of these and the strategies that you can use to not only answer them, but the different ways to answer them depending on the problem type. So this video is going to help you a lot. If you're someone who maybe struggles with some of the math skills here and there, you maybe haven't been exposed to some of these problem types in your math classes, for whatever reason, maybe your teachers weren't that great or you weren't paying attention in class. Again, all those are good reasons. It's fine. It happens. So watching this type of video will help you understand some of those skills because all the skills are covered here, okay? I also recommend that before you watch this video, you take this exam. Take the whole thing. The PDF is available on our website. You can download it for free, take the test, do it with the timing on your own, and then grade it. There's an answer key at the bottom of this PDF. I'm obviously not going to show it to you. And then once you're done grading it and seeing which correct problems you got right, which ones you got wrong, come to this video and see what problems, like watch the video specifically for the problems that you didn't understand and that you got wrong. And that'll help you learn from your mistakes. The key here is we want you to learn from your mistakes because that's how you bridge the gap between your score and a 36, okay? We want to bridge that gap. Your score and your target score should be the same score. And the way you're going to do that is by filling in the gap, which is through skills, okay? You got to learn skills. All right, that's what this video will help you with. So be sure to head to the 5academy.com/free. It's linked above in the link below. Try the test yourself and then watch this video and let's see how you do. Let's get started with this full math practice test. Pranav runs a luxury car dealership selling cars from 4 different brands. After a successful summer sales event, he has remaining 6 cars from brand 1, 7 from brand 2, 12 cars from brand 3, and 18 cars from brand 4. Approximately what percent of cars are from brand 2? Okay, so from brand 2, if we want to calculate what percent or what proportion of cars are from brand 2, we can treat it like a probability problem. So what's the probability of randomly selecting a car in the lot and having that car be from brand 2? So the probability of brand 2, the way you calculate that is you have a fraction. The numerator of the fraction is going to be the number of desired outcomes. Okay, so in this case, it's going to be 7 cars. We want to choose one of those 7. The denominator is going to be the number of total outcomes, and that's essentially just the sum of 6, 7, 12, and 18. Okay, that comes out to 7 over 43. And if you calculate that, you end up getting 0.16 going on. And that's what B is approximately for 1. 3x minus 6 equals 18. So what is x? Okay, so the way you can do this is you can distribute the 3 to x and 6. So you get 3x minus 18 equals 18. Then you can add 18 on both sides. 3x equals 36, and then divide both sides by 3, x equals 12, okay? If you don't know how to do this algebraically, you can just plug in numbers for x and see which one gets you the right answer. Corporation X sells television sets in 3 variations. Their gross income last year consisted of S small TVs, M medium TVs, and L large TVs. They cost this much each respectively. So which of the following expressions models their income last year? So we see a variety of different algebraic expressions kind of adding these 3 variables together with different multiples. The way you're going to do it, think of it piece by piece. So if I bought 3 small TVs, right? What would that cost be? It would be the number of TVs, 3, times the cost per TV. Overall, that's going to be a $1,200 cost. Effectively, what I just did is if S is the number of TVs, I just multiplied by 400 to find the total cost of that many S TVs, that many small TVs. Same goes with M times 600 and L times 1,000. If I add these 3 terms together, I get a sum of all TVs and the total income or revenue across all of them. So 3 is going to be C. H of x is defined as this. Which of the following is h of 5? Okay. The way you're going to do this is just take x, get rid of it, and substitute 5 in for all the x's. Okay, so let's do that. 3 times, does that mean your answer is going to be 35 squared here? Not quite. It's going to be 3 parentheses 5 squared plus 4 times 5 plus 6. That turns into 3 times 25 plus 4 times 5, which is 20. Let me just evaluate that. Plus 6. That turns into 75 plus 26, and that's 101 if you do it on your calculator. Very simple. Another way to solve this is if you don't want to do the algebra behind this, you can just plug this equation into your calculator and write it out and let your calculator solve it if it's a TI-83 or TI-84, or you could even graph the equation and see what value of y you get at the x value of 5. Quick fill gas station charges $3 per gallon plus a $2 service fee per fill up. Their competitor across the street, Speed Trip, charges $3.25 per gallon plus a $1 service fee per fill up. How many gallons need to be purchased in one fill up for the costs to be equal? Okay, so the quick fill, I'll just call it Q, the cost is going to be $3 per gallon plus X gallons, or times X gallons plus $2, right? So for example, if I get 5 gallons, the total cost is going to be 3 times the number of gallons plus 2. That comes out to $17. So we can intuitively create this equation, right? If I have any number of gallons, it's just that gallon value multiplied by 3 plus 2. Okay, very intuitive, simple equation. Now what you'll notice is this is actually y equals mx plus b form. That's why it's so applicable, the slope-intercept form. Okay, but just keeping that in mind. And then the other gas station is Speed Trip. That cost is equal to 3.25x, where x is the number of gallons, plus 1, okay? What are we looking for? We're looking for the number of gallons, which is, in this problem, I specify as x, where the costs essentially are equal. So if C represents cost, what we could just do is, let's label this as C1, C2. We want to find C1 equals C2. What value of x makes C1 equal C2? If C1 equals C2, and this is what C1 is, and this is what C2 is, then really I can just rewrite this as this. And then just solve for x. This becomes minus 1, minus 1, minus 3x, minus 3x. Let me just do this in one step just so it's a little bit easier to understand. So I'm going to just start by, I want to isolate x. I want to get all of the x's on one side of the equation and get their constants on the other side. Okay, so I'm going to start by subtracting 1 on both sides so that this 1 cancels out and I isolate 3.25x. So 3x plus 1 equals 3.25x. Now the last step to isolate x is subtract 3x on both sides here so that I move the x again to the side where I want x's. This cancels out. I end up getting 1 equals 0.25x. And then, okay, this is the last step. It's to divide by 0.25. Okay? If you don't know what 1 divided by 0.25 is, just do it on your calculator. X will end up equaling 4. Okay? So after 4 gallons, you can check this equation just to see. You will have the same value. Now, if you don't want to do all this algebra, if it doesn't make sense to you, you can solve this by plugging in each of the answer options into both equations and seeing which value gives you the same cost. Hey, do you want to improve your ACT score? Yeah. Do you want to improve a lot within like 2 to 3 weeks? I mean, like, I guess, yeah. Great, you should check out the5academy.com. Students have used our software and our tutoring and have improved up to 10 points within just a few weeks. And not only that, but our software will give you diagnostic quizzes and personalized content depending on what you specifically need and want help with. You can even get one-on-one tutoring with me if you enroll in our program. Be sure to check out all of our content linked down below. We have free and paid content for everyone. Essentially. 10 gallons of jet fuel consist of 3 gallons of solution A, 3 gallons of solution B, 1.25 gallons of solution C, and 2.75 gallons of D. How many gallons of solution A are needed for 17 gallons of jet fuel? Okay, so we're focused on 17 gallons of jet fuel, 10 gallons of jet fuel, and 3 gallons of solution A. Why did I focus on these two? It's because this ratio has to be true. For every 10 gallons of jet fuel, there is 3 gallons of A. Now, if I set this equal to some unknown number of gallons of A, and I know I have 17 gallons of fuel, I can calculate this unknown. So let me just set this equal to x, for example. What I just did is I created an equation that I can solve for x. The equation is just 3 over 10 equals x over 17. You can solve this by cross-multiplying and dividing, or just multiply 17 on both sides. So you get 17 times 3 over 10 equals x, and that's equal to 5.1. Do it on your calculator. 6 is D. If 15 to the x squared plus 6x plus 12 is equal to 15 to the third, then what's x equal to? What you can do is, since the bases are the same, you can just set the exponents to be equal to one another. Okay? You know how to solve this. This is a quadratic equation, so I can subtract 3 on both sides, move everything to one side of the equation. So now it's equal to 0. And then I can factor this. So we think of factors of 9. What are the factors of 9? 1 and 9, and then we have 3 and 3. Factors of 9 that equals 6 when you add them together, clearly these two. So I can set my factors with x plus 3 equals 0. That means x has to equal negative 3. I just set one of these to be equal to 0, subtract 3 on both sides, and that's where I get this. Okay, x has to equal negative 3. The following figure is a rhombus divided in half. Which of the following must be true? Angle A has to be equal to angle B. Okay, so maybe. It clearly doesn't look like it. Angle A looks to be a little less than 45. Angle B looks to be a little bit more. But think about another rhombus that might be a little more extreme. So let's say I have one that looks like this. Okay, very extreme. And that means that this is going to be angle B, this is going to be angle A. Clearly, angle A is much smaller than B. Okay, so that can't be true. If you look at option E, it's saying the same thing, really. It's comparing the corner angle, the tip angle, with one of the inside angles. And again, essentially, answer option E is saying this angle out here is the same thing as this angle here. This angle is much bigger than this one, so that doesn't make sense. Again, answer option E is saying this angle here is the same as this one. But the bottom one is much bigger than the top one, the corner one, okay? So for that reason, A and E are both out. Now, what is answer option B saying? Answer option B says angle B is equal to angle C. So if we come back to this example right here, right, this very extreme example, let me make it a bit neater so we can see a bit better. So let's make it very steep. That's not the best. Let's do it like this. There we go. So if angle B is equal to angle C, what that means is that this angle would be equal to this angle for any rhombus, not just this rhombus, but for any rhombus. Clearly, this B and this C are not the same. C looks to be much bigger than B. In this case, C and B look to be very close, right? But that, again, that doesn't apply for every rhombus. So for that reason, that's out. And you'll notice option D says D is equal to E. That's really saying the same thing, D and E being the same. It's really saying the same thing as B, and for that reason, that's also wrong. Okay? Now, if you look at option C, it's saying that C and D are the same. Okay? Let's look at the two rhombuses that I've made, and let's find C and D. I have C labeled here. I have D here. They look to be about the same in both of these examples. These two look to be about the same, and in fact, they are the same. Now, why is that? It's because of alternate interior angles. These are both interior angles, and they are on alternate sides of the line, of this line that essentially divides them, separates them. So for that reason, they are the same angle measure. The sum of A and B is 25, and the quotient of A and B is 1.5. What must be the value of A times B? Okay, so the sum of A and B is 25. What does that mean? That means that when you add A and B together, you get 25. Here it says the quotient of A and B is 1.5. What is the quotient? It's when you divide one by the other. Okay, now it doesn't matter if you do B over A or A over B, because at the end of the day, what are you looking for? A times B. And A plus B is commutative. Like, it doesn't matter if you write it as A plus B or B plus A. The order doesn't matter in this particular problem, so it doesn't matter how you assign them, okay? You'll get the same answer regardless. Now, what do we have here? We have a system of two equations with just two unknowns, so I can solve, essentially, for these two variables, okay? Let's start by multiplying by B on both sides here so I can solve for A, and then I'll plug this A in up here, and I'll have this equation only in terms of B, and I can solve for the value of B, okay? So first, like I said, multiplying both sides of here by B, these two cancel out, we get A equals 1.5B. Now I can take this A, plug it in here. 1.5B plus B equals 25. I can combine these two, I get 2.5B equals 25. Divide both sides by 2.5, that means B is equal to 10. Okay, now using that, and the fact that I know that A over B is equal to 1.5, I can write this as A over 10 is equal to 1.5. Multiply both sides by 10. We get A equals 1.5 times 10. That's equal to 15. Now, if A is equal to 15, B is equal to 10, what's A times B? 150. All right, simple as that. When y equals 1/3, which of the following is the value of this? Let's write out the whole fraction and plug in the value. 15 times 1/3 plus 9 times 1/3 all squared divided by 1/3 plus 2/3. So we have essentially three terms we need to solve. Okay, the first one, if I solve it, 15 times 1/3, you can do that on your calculator. If you really want to type it in, you could type in 15 times 1 divided by 3. Sorry, a little bit of a syntax error. We get 5, okay? Plus, if again, you can do this on your calculator if you're not sure how to write it out. It comes out to 9 times 1/9. But again, if you're not sure, your calculator is always there as a backup. So let me write it as it is written in the problem. You get 1, okay? And this right here is just adding fractions. It turns into 3/3, which is just 1. This turns into 6. So your answer here is 6. Very simple. Consider the following linear equations. Which of the following accurately describes the solution sets for the two equations? So the way you can do this is rewrite, at least what I would do, is rewrite them in y equals mx plus b form. Because when you have them in this form, you can immediately understand everything you need to know about how these equations look. You know the slope, whether it's positive or negative, whether the lines are going to intersect or not. If they have the same slope, then they might not intersect. If they have different slopes, then they have to intersect, right? And that means that they would have at least one solution. Okay. You can also find out the y-intercept. So that tells you, like, if they have the same y-intercept, then that means that if they have this to be the same and this to be the same, that could very well mean that they have an infinite number of solutions, that really they are just the same line overlaid on top of each other. All right, so let's convert into that form. The way we can do that is just solve both these equations for y. So I'm going to subtract 3x on both sides first. This turns into 4y equals negative 3x plus 12. Divide everything by 4 to isolate the y. We end up getting y equals negative 3 over 4x plus 3. All right, that's your first equation. Now for this one, we do the same thing. Subtract half x on both sides. 2/3y equals negative half x plus 22. And then, again, I want to isolate the y. So what can I do? Multiply everything by 3/2. Because if I multiply a fraction by its reciprocal, they will cancel out and just give me 1. Okay? So everything gets multiplied by 3/2. So we end up getting y equals 3/2 times negative half x plus 22 times 3/2. And I can simplify that a little further. Y equals 3 times 1 divided by negative 2/2, or negative 2 times 2. That's negative 3/4. X plus 22 divided by 2, that gives me 11. So I'm going to get 11 times 3, 33. These are my two equations, this and this. What do I notice? When I compare to y equals mx plus b, they have the same slope, so they're parallel, but they have different y-intercepts. So the lines are going to look like this. They're going to go on forever and ever without intersecting, which means that they don't have any solutions at all. Let's solve this absolute value equation right here. So what do I notice? I have 6 different brackets that are listed. Obviously, they come in pairs. So these two here obviously kind of go together. So really, the hard part is worrying about this, okay? We have an inside pair here and then an outside pair here. Let's solve the inside first. So the absolute value of negative 14 is what? 14. So the inside turns into 8 minus 14 plus 6, absolute value. This whole thing is just 0, so this entire thing vanishes. It's all just 0, okay? So your equation comes out to 0 minus absolute value 8, which is just 0 minus 8. Okay, remember that when you have an expression like this where it's negative 8 minus 6, you still keep the negative. It's really the same thing as doing negative 8 plus negative 6. And that's still going to give you a negative answer. But if it was negative 8 minus negative 6, that's where you have two negatives next to each other, and that turns into a plus. Negative 8 plus 6 was negative 2. All right? The greatest common factor of these two numbers is what? To find the greatest common factor, there is a proper, correct way to do it. There's also a very reverse backsolve cheat method of doing it. Of course, it's allowed. So let me show you both. The cheat method of doing it is to take each of these numbers and divide it by each of the answer options. You want to find the greatest answer option out of all of these that essentially that you can divide all three of these numbers by. So for example, let's just test 20, okay? So 60 divided by 20, 75 divided by 20, 120 divided by 20, okay? All three of these numbers should be divisible by this if 20 is a factor of all three of them, if it's a common factor, okay? Now 75 divided by 20 gives you a decimal, so that doesn't work. Let's try the same thing with 15. 60 over 15 equals 4, 75 over 15 equals 5, and 120 over 15, I think it equals 8 or something like that. So for this reason, since it's the biggest answer option given to you that works, it has to be the greatest common factor of these three numbers. Okay, that's one way to do it. The other method is to draw out the factor tree of all three of these numbers, do the prime factorization. So 60 is the same thing as 2 times 30, which is the same thing as 2 times 15, which is the same thing as 3 times 5, okay? So you write out the factor tree of that. This is 5 times 15, which is 5 times 3. Okay, and then 120. This one's going to be a bit longer. So let me put this here. So you end up getting 2 times 60, 2 times 30, 2 times 15, 5 times 3, 2 times 2 times 2, 2, 3. Okay, now what do you do with these factors? These are prime factorization. What you do is you essentially find the numbers that all three prime factorizations have in common. So we notice they all have a 3. So let me circle that. They all have a 3. What else do they all have in common? They all have a 5. One singular 5. Okay? Whatever numbers they have in common, you multiply them together, and that's your greatest common factor. Because if you think about it, that's the greatest common combination of factors that they all share. Okay? So that's the proper, correct way of finding greatest common factor. The circle graph below is a depiction of this person's automobile expenses over a certain period of time. Given that she spent $800 total over this period, which of the following is the degree measure of the missing chart value? Okay, so the first thing I can do is I can find that value by just subtracting. So I can take 800, and then I can subtract 250, and 150, and 100, and 200, and I end up getting 100 for that portion right there. Now, it's not 100 degrees. That's just $100, okay, out of 800. The way that you find the degree measure is you take the proportion of the entire circle that $100 is, which is 100 divided by 800, and then you multiply that by the total number of degrees of a circle. This will give you, this reduces to 1 over 8. So by doing this operation, you're really just doing what's 1/8 of 360 degrees. That's the amount of degrees that will be devoted to this part of the graph. This comes out to 45 degrees. Michael's 5 math test percentages are 81, 82 in these. If the lowest score is dropped and replaced with the average of the original 5 scores, which of the following is the new average score rounded to the nearest percent? Okay, so let's find the original average. The way you do that is just by adding all the numbers together, divide by the number of numbers. So if I do that on my calculator, 81 plus 82 plus 95 plus 86 plus 93, divide that by 5, you end up getting 87.4 is the average, okay? Now what we have to do, essentially, what the problem is asking is take that that lowest number and substitute in your original average, okay? And then recalculate the average. The new average is going to be 87.4 plus 82 plus all that plus 93 divided by 5. So I'm going to do that on my calculator. So we end up getting 82 plus 95 plus 86 plus 93, divide that by 5, 88.68. If you round that, you get 89%. Okay, so the average goes up by about, 2% or 1%. The 2 points are in the standard coordinate plane. Which of the following is the distance between the two? So the proper way to do this is with distance formula. I'm going to give you an easier way to think through it that is not involving the distance formula. It's indirectly visualizing the distance formula, okay? So the first step is to draw your XY coordinate plane and then to plot the points. So 4, 8 is like up here, and -5, -4 is somewhere down, let's just put it here, okay? Then we have this distance that we're trying to find. Let's label that D, okay? Now, the key is, I'm going to turn this into a triangle. Let's make this a solid line because we're looking for that. All right. If I can find, obviously this is a right triangle. If I can find this dimension and this dimension, I can find the distance. Just Pythagorean theorem, right? So what's this dimension? Well, really what I'm doing in this dimension is I'm going from -5, -4 to 4, 8. This dimension is only a change in x. I'm only going to the right to go from here to here. So how far do I have to go to the right to get from -5 to 4? Again, 4, -5. How far do I have to go? If you think about it, this is 4 units away this way, this is 5 units away this way, so it's really just a matter of 9 units. Vertically, you do the same thing. You think, okay, if this distance is 4, because it's -4, right? And this distance is 8, well, the sum is just 12. So this distance is 12, this is 9. I can calculate d by just doing 9 squared plus 12 squared is equal to d squared. D is going to give you 15. Okay, now literally this is exactly what the distance formula is. If you think about it, the distance formula is distance squared equals x2 minus x1 squared plus y2 minus y1 squared. It's two numbers squared equals the last number squared. And this x2 minus x1 is really just this distance here. It's the x2, which is 4, minus -5, and that gave us 9. The y2 minus y1 is the same thing. It's 8 minus -4. Okay, it's just a complicated way of writing it that most students forget, so I always recommend visualize it. It's a lot easier. Consider the two lines in the coordinate plane. Which of the following is the value of the first line's slope divided by the second line's slope? What's the first line's slope? Again, we need to come back to y equals mx plus b form. So the way that you convert this to this, you have to think, is my y isolated? It's kind of isolated, like it's by itself, but there's still a 2 in front of it. So the way you get rid of that 2 is by doing the opposite of what the 2 is doing to the y. The 2 is multiplying the y, so we're going to divide everything by 2. Now the 2 is gone, we end up getting y equals 3 over 2 x plus 2. Same thing here. We need to divide everything by 5 to isolate y. Y equals 6 over 5x plus 5. Sorry, plus 2. All right. Now, the first line slope is 3 over 2. So we're looking for the first line slope divided by the second line slope, which is 6 over 5. That's 3 over 2 times 5 over 6. That comes out to 5 over 4. Okay? That's your answer here. It's just finding slopes and then dividing. The following table displays Shaw's income over the past week. Which of the following is the difference between the mean, median over the last week? So the mean I can calculate by just adding up. Again, what's the mean equal to? It's where you add up all the values and then you divide by the number of values, okay? So in this case, if I just add all these up on my calculator, we'll end up getting 100 plus 130 plus 105 plus 245 plus 200 plus 175 plus 95. Divide that by 7, because it's 7 days in the week. We end up getting mean equals 150. What's the median going to be equal to? So the median is what I get when I list all these numbers out in increasing order. So 95, 100, 105, 175, 130, 175, 200, 245. Okay, and then you start canceling out numbers on the right and left, right, left, right, and then I get a middle number. That's my median. Okay, you're only going to get a middle number if you have an odd number of values. If you have an even number of values, you're going to get 2 middle numbers, and in that case, you have to take the average of those 2 middle numbers, and that's going to be your median. So the question asks, what's the difference between the mean and median? It's just 20. So that's your answer. Which of the following is equivalent to y raised to the 5 over 2? So we have to essentially know our properties of exponents here. So y to the second divided by 5. This is not quite it, because just dividing by 5 is just going to be equal to 1 over 5 times y to the second. So this is wrong. E is wrong for the same reason. As for b, how does a square root come into this? Well, a square root is really just the same thing as taking that fraction and raising it to the half, okay? So y to the 5th square root is the same thing as y to the 5th to the half. And when I have an exponent to the exponent, what do? if you remember your properties of exponents, you just multiply the exponents together. So that ends up coming out to y to the 5 over 2. Okay? So y to the 5 over 2 is equal to square root of y to the 5th. So B is your answer. Now let's go through C and D just to confirm that they're wrong. So C, what does y to the negative 2 over 5 equal? Well, that would be the same thing as y to the 2nd to the 5th root, right? Because that's the same thing as y to the 2nd to the 1 over 5. This would also be the same thing as y to the 1 over y to the 2/5. Okay, because a negative just changes the numerator and denominator. In this case, your numerator and denominator is just y and 1. So that's how that works. Now, as for answer option D, these two are the exact same thing. I just described that the negative just flips the numerator and denominator as such. Okay? When will the product of two integers m and n always be a negative integer? Two integers, m and n, always be negative integers. So let's just go through each answer option and check it. It's kind of a hard problem to conceptualize just in our heads. So if m and n are both positive, so let's just take any two positive integers like negative, let's take 3 and 4. If I multiply them, that's the product, right? A product is when you multiply two things. I get 12. That doesn't give me a negative integer, so this answer can't be right because it says always. So this is saying for any and all positive integers or integers in general, is this rule always met? And the answer has to be yes. In this case, the answer is no, because I just came up with some integers, just two of them, where the criteria does not meet. Okay, m and n are both negative, so let's just do the same thing but make them negative and test what we get. We want to get a negative number. This gives us a positive number. When you multiply a negative and a negative, you get a positive. What about if one is negative, the other is positive? So if I do negative 3 times 4, yeah, this gives me a negative number. So in this case, I found an example that works. That doesn't mean that it's necessarily correct, but it's an example that does work. Okay, so we can keep that in mind. Let's check the other answer options. M is a negative integer. So let's say m is equal to negative 3. N, however, if n is also negative, then this will work. But if n is positive, such as, n equals 5, if n is positive, this will work. But if n is negative, then this doesn't work because you end up in the same case as B. Okay, so this doesn't always apply because there's still a case for n where it messes it up. M is an odd integer. Odd even has nothing to do with this. You can come up with m equals 3, n equals 3, or 2. You end up getting 6. It's not negative, so that's how that works. Let's do problem number 21. So we have a 30, 60, 90 triangle below. The shortest side has a length of x and the hypotenuse has a length of 2x. So which of the following must be the length of the other side in terms of x? Okay, so the way we can do this is first assign the sides. So the shortest side is x. The hypotenuse is 2x. How do I know that's the hypotenuse? It's because here I clearly have a right angle, and the right angle opens up to the hypotenuse, the longest side. Okay? All right. Now, how do we find this last side? Let's call it y. The way you find that is you can use your ratios. So I can say that I can relate 30 degrees to x or to 2x using opposite over adjacent or adjacent over hypotenuse. So for example, cosine of 30, which is a value I can plug into my calculator, that's equal to adjacent, which is y, divided by 2x. Okay? Cosine of 30 is equal to square root of 3 over 2, equal to y over 2x. Now, if I essentially multiply this by x over x, what happens? My denominators match, so my numerators have to match as well. That means square root of 3 times x has to equal y. So effectively, I just solved the problem. X squared of 3 is equal to y, just by adjusting my denominators and getting a common denominator, okay? That's one way to do this problem. The other is to do the Pythagorean theorem. So just put x to x, and say y, that means that x squared plus y squared is equal to 2x all squared. That means that x squared plus y squared is equal to 4x squared. Y squared is equal to 4x squared minus x squared. If I subtract x squared on both sides, then y squared is equal to 3x squared. Y is equal to square root of 3x squared, which is equal to x squared of 3. Okay, that's another way to do this problem. The very last way that I'll show you is where you just set x equal to 1. Okay, so this is 2 times x, this is 1 times x, and you can do Pythagorean theorem again. You'll get the same thing. 2 squared is equal to 1 squared plus y squared. Essentially, 4 is equal to 1 plus y squared equals 3, y equals square root of 3, okay? And you just attach the x on the end because x is equal to 1. So 21 should be A. Scientific notation. The way you can do this is divided into two different problems. Think of it in two different segments, okay? So the first segment, you're multiplying the first decimals together, okay? 3.2 times 2.5 is just 8, so that means A, B, or C have to be your answer. The second segment of the problem is where you multiply the underlined portions. You multiply the exponents together. So 10 to the negative 12 times 10 to the third, what's the product here? Okay. Now, if you remember your exponent rules, when you multiply two exponential expressions and they have the same base, what you can do is just add the exponents together. Okay, do the sum of the exponents. You do the same thing here. They have the same base of 10, you keep the same base, and you just add the exponent. Okay, so 10 to the negative 12 plus 3. Negative 12 plus 3 is equal to negative 9, so 10 to the negative 9. 8 times 10 to the negative 9 is your answer. In order to solve this, we have to do a little bit of distributive property, and then also again work with exponents, kind of using the same rule that I described up above here, this one. So 4x to the 12th times this. So what's that going to be? It's going to be 4 times 3 times x to the 12 plus negative 11. Okay? Then I'm going to add that to 4x to the 12th times 5x to the negative 10. So 4 times 5 times x to the 12th plus negative 10. Right? And then at the end I subtract 10x squared. I can simplify that to 12x to the, what's 12 plus negative 11? 12 plus negative 11 reduces to 12 minus 11, because when you have a plus and a negative like this, the negative overtakes. This just comes out to 1. So it's just 12x, okay? Now we add that to 4 times 5, 20x to the 12 minus 10, and then subtract 10x squared. This is close to being done. I just have to combine like terms. The x squared terms can be added together. 12x plus 10x squared. 23 is A. In a physics experiment designed to examine gravitational acceleration, Joseph drops a ball that has a speed sensor attached to it. The speed sensor's readings provide the table depicted below. T corresponds to a time in seconds, and S to S to speed in feet per second. So, which of the following equations accurately represents the data? So, we see that the speed steadily increases, time steadily increases as well. The data based on the answer options should be linear, which means that it should be something of the form y equals mx plus b, right? So in order to do that, in order to write an equation of this form, we need to know the slope. Slope is going to be equal to y2 minus y1 divided by x2 minus x1. In this problem, we don't have x and y, we have t and s. So I can rewrite this as s2 minus s1 divided by t2 minus t1. Let's pick any 2 points. So I'm going to say s2, t2, let's say t2, s2 equals 0.19, and then t1, s1 equals 0.6. Okay, now let's do the formula. S2 is 9 minus S1 divided by T2, 0.1, minus T1, 0. You end up getting 30. So your slope has to be 30. So it's either A or B. The only difference now is the y-intercept. Do we have a y-intercept of 6 or a y-intercept of 0? So the y-intercept is going to be the value where x is 0. So it's the y value when x is 0. So here we see when x is 0, y is 6. So that's going to be our answer. If you're not sure about what I just said, if that doesn't make sense, what you could do is just take any one of these points and plug it into this equation of this form. So just plug in an x and y coordinate along with your m value that we calculated into this equation and then solve for b. So that would look like if I do this equation, I'll do 24 equals y, and that is all equal to 30 times 0.6 plus b. Okay, 24 times 30 times 0.6 is equal to, let me just delete this, 30 times 0.6 is equal to 18, so 24 equals 18 plus 6, or 18 plus b, sorry, it does equal 18 plus 6, that means b is equal to 6, all right? That's how you do the y-intercept, both ways. You find a stop sign and place rubber bands on the corners of the stop sign, connecting each corner to each of the other corners of the sign. How many rubber bands will be needed to connect every corner of the stop sign with all the other corners of the stop sign? So the best way to do this is to visualize it. Let's say I have a stop sign, make that a bit smaller. So we have a stop sign like this. Okay, what I'm going to do is essentially I'm going to pick a corner and I'm going to start drawing these lines, these rubber bands that extend to all the other corners. So we start here, 1, 2, 3, 4, 5, 6, 7. Okay, so from this point we have 7 rubber bands. Let's go to the next spot. We have 1 rubber band, 2, 3, 4, 5, 6. And then I noticed this last one, I already have one here. So I'm not going to place another one there. It's a repeat case. So I have 6. Let's do the same thing here. I have 1, 2, 3, 4, 5, 6. The 6th one, though, again, is a repeat. I already did that in the last case. You can kind of see the pattern. It just decreases by 1 each time because one of those later rubber bands just gets taken up. So we can continue this 4, 3, 2, 1. And then by the time we get here, there's 0 left. Everything's been connected already. If you add up all these numbers, you end up getting, if I do it on my calculator really quick, so you should get 7 plus 6 plus 5 plus 4 plus 3 plus 2 plus 1 is 28. Circle 1 has a radius r and area a. Circle 2 has area capital A, which is double the area of circle 1. If the area of circle 1 is given by this equation, which of the following is circle 2's radius expressed in terms of r? Okay, so first of all, what do we know? We know that area A, the bigger one, is double the area small a, okay? And we know that area is equal to pi r squared. I'm going to denote the larger radius as capital R and the smaller area with pi lowercase r squared, okay? So we know these three things, and we want to find a relationship of r, capital R, is equal to something, 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 lowercase r, something, 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 okay? So how can we do that? What I can do is take this relationship and just plug in capital A and lowercase a, okay? So that would look like pi capital R squared is equal to 2 times pi lowercase r squared. Divide both sides by pi because that's repetitive. R squared capital equals 2 r squared lowercase, and then I end up with r, if I take the square root of both sides, r is equal to square root of 2 r squared, which is equal to r square root of 2. R equals r squared of 2, okay? That's how you solve this. Which of the following is not a solution of the following equation? So we had this equation. What are the solutions going to be? It's just going to be when we factor this out, what are the different x-intercepts essentially. So I can factor this using difference of squares, where I remember that a squared minus b squared is equal to a plus b, a minus b, where in this case, a is equal to x, b is equal to 1. Okay, so a plus b, a minus b is going to be x plus 1, x minus 1, right? X minus 1. That's the first thing. All right, then this part, I can factor out an x, just divide both of those by x, and then what I'm left with is x plus 5, and all that equals 0, okay? Now I can set each of these to be equal to 0. X equals 0, x equals negative 5. Sorry. X equals 0, and then x plus 5 equals 0. And then I end up getting, if I solve each of these for x, I get all the solutions. X equals -5. So -5 is a solution, -1, 1, 0. 5, however, is not a solution. If I plug in 5 here, this does not actually equal 0. Now, if you didn't understand this process, what you could just do is plug in each of these answer options into x up here and verify that it's actually equal. The only one that it won't equal is when x equals 5. You'll get 5 squared minus 1 times 25 plus 25, and that does not equal 0. Okay? If 20% of this number is 5 over 3 of x, x is what? So 20% of 75, how do you express this? How do you express this whole thing mathematically? The way that you do that is you start by taking it bit by bit. So 20% of 75, the way you express that mathematically is you rewrite the 20% as a decimal by just dividing it by 100. So the decimal equivalent of 20% is 0.2, okay? Then I multiply that 0.2 by 75, and then it says that this is 5/3 of x. So 5/3 of x is just when I multiply 5/3 times x, and the is really just an equal sign, okay? So now what do I have? I have an equation here that I can solve for x. If I isolate x and just move everything to the side, I have effectively solved the problem. So the way I can solve for x is just multiply by the reciprocal of 5 over 3 on both sides. The reason I multiply by the reciprocal is because I know this fraction will cancel out if I do that. A reciprocal times a reciprocal is just equal to 1. So x is equal to all of this right here. So 0.2 times 3 divided by 5 times 75 is 9. All right, 28 should be C. In this problem right here, we have some complex and imaginary numbers. So how do we go about solving this? Let's take it bit by bit. So if I rewrite, let's start just with this. 15i times I. Okay? The way that you solve this, it'll obviously just become 15i squared. We need to keep in mind that I squared is equal to -1 square root. Okay? Sorry, that's I is equal to square root of -1. That means that I itself is going to be equal to, I squared is this, I is equal to square root of -1. Okay? So wherever I see I squared, I can just substitute in -1. This becomes 15 times -1, which is just -15. All right? So that's simple enough. This in front here is just -15. Okay? And then -15 times 1/5 I is going to be, is just -15 over 5 times I. -15 over 5 is going to just be -3. So -3i. Okay, so this whole front thing we've reduced to -3i. Now -3i times 4i plus 5 is equal to, we just essentially distribute. So -3i times 4i is -12i squared. -3i times 5 is -15i. We remember that I squared is just the same thing as -1, so -12, -1, -15i is equal to 12 minus 15i. Given the following triangle, which of the following is the value of sine theta over cosine theta? Sine theta divided by cosine theta is, so we can calculate each one. Sine theta is equal to opposite. So we know that the opposite side relative to theta is the side that the angle opens up to, okay? C. Over hypotenuse. Hypotenuse is the side that's opposite of the right angle, okay? So that's going to be the longest side. Cosine theta is just that other side that we didn't take into account. It's also the side that is touching the angle theta. So the angle theta is touching two sides, right? One of them we know is the hypotenuse. That other one is the adjacent side. And the one that's opposite is hypotenuse, okay? That's a little bit of a synopsis of the three different types of sides. So we know the adjacent side is B, hypotenuse is A. So we're asked for sine theta divided by cosine theta. C over A divided by B over A is the same thing as C over A times A over B, because dividing by a fraction is the same thing as multiplying by its reciprocal. The A's cancel out, we get C over B. Notice that this is the same thing as tan theta, which is opposite over adjacent. Tan theta is the same thing as the ratio of sine to cosine. It's Ron's birthday and he's purchased a circular cake for him and his birthday party guests to eat. He eats 1/9 of the cake and the rest of the party eats 2/3 of the cake. How much of the cake is left? Okay, so originally there's one cake and then he eats 1/9 of it. So after he eats it, that's how much is left for everyone else. And then the rest of the party eats 2/3 of it. So this is the remainder that we're asked about, okay? So how do we find this value? Well, you could plug this into your calculator. So let me just do that really quick and just kind of cheat your way through the problem. So you end up getting 0.22. Oh, this is a weird calculator. It gives me the fraction form. That's kind of a way to do it. And if your calculator doesn't give you the fraction form, if it just gives you 0.2 repeating, you can just check each of these and see which of them equals this. Like plug in 1 divided by 3 into your calculator, and plug in 4 divided by 9, etc., and find which decimal matches up. Okay, that's one way to do it, and that'll get you the right answer, guaranteed, as long as you know how to type something into the calculator correctly. If you want to do it the proper way, you can find a common denominator, which in this case should be 9. So convert this to 9 divided by 9 by doing this essentially. So you do 1 times 9 over 9 minus 1 over 9 minus 2 over 3 times 3 over 3. So you get 9 over 9 minus 1 over 9 minus 6 over 9. You end up getting 2 over 9. You just essentially subtract the numerators and then keep the denominator the same. Use the following info to answer these next few questions. He is replacing his house's damaged roofing to access his roof. He has set up a ladder on the side of this one-story house, which is 12 feet high, on its exterior. The ladder makes an angle theta with the ground as shown in the left diagram, and the roof's top-down view is provided in the right figure with measurements in feet. There's also a circular ventilation structure of diameter 10 feet on the roof. That's this probably. Which expression gives the distance of the base of the ladder from the wall of the house? So this is the ladder. This is the wall. So we want this distance from the base of the ladder to the wall of the house. Relative to theta, we know this is opposite, hypotenuse, adjacent. Because again, adjacent is the side that's touching. I just broke those 3 down in this problem, number 30. So if you want a definition of each of those, check that out. So the distance from the base of the ladder to the wall of the house. So if we just look at our sine, cosine, theta, sine, cosine, tangent, let's just see if we plug these in, what do we get? So sine theta is equal to opposite, which is 12, over ladder distance. Cosine theta is equal to adjacent, which is, I'll call this the base distance, and that's the distance we're looking for. Okay, so that's the base distance divided by the ladder distance, and tan theta is equal to the opposite side, which is 12, divided by the base distance, which is the adjacent, okay? Now, out of all of these, I see all of these in the answer options. Cosine theta, well, actually, let's see. Which of these can I actually solve for the base distance? Sine theta is useless because it doesn't have the base distance in it. It doesn't give me, it just characterizes this, this side and this side. It doesn't characterize the base side, and it doesn't include in the equation, so that doesn't really help. If I solve this for b, I get L cosine theta. If I solve this for b, I get essentially by multiplying b on both sides. Those cancel, we end up getting b tan theta equals 12. I can divide both sides by tan theta. b equals 12 over tan theta. Now these are 2 solutions for the side length b. Okay? It does not match this, does not match this, does not match, sorry, it does match that. It doesn't match any of these except for this, okay? So if I saw this in the answer option or this, then I would have the correct answer. We're essentially looking for which sine or cosine or tangent ratio gives us the actual approximation, or gives us the actual value that we're looking for. I think all of these are true. Like at least these are based on true relationships, but these don't give us the right value. So you have to just search for the right value. The area of a circle is this. What percent of the roof's area is taken up by the circular ventilation structure shown? So the roof's area is all of this. The ventilation structure is this. So we just have to find what's the area of this, given that it's a diameter of 10 feet. So area equals pi times radius squared, where r equals 5 feet. So area is equal to pi times 5 squared. That's 25 pi, okay? Now that's the area of the ventilation structure. What's the area of the roof total? That's going to be the length times the width, because we're assuming it's a rectangle. So 108 times 68. Do that on my calculator. So 108 times 68, 7344. And since we're looking for percent of the roof's area, we just divide the ventilation area by this area. Okay, so 25 pi divided by 7344 is equal to what? 25 times pi. So I'm going to have to use a special character. There we go. Divided by 7344. We get 0.01069, which is about 1.07%. The way that we know that is you can move the decimal 2 places to the right by just multiplying the decimal equivalent by 100. That'll give you the percent form. So you get 1.069%. Okay? It's about B. He uses a hydraulic construction lift to bring up 300 square feet of roofing per lift. Assuming no roofing will be placed over the circular ventilation system, how many lifts will be needed to bring enough roofing for the entire rest of the roof? So we effectively need to find how much area is taken up by all of this, excluding the dark gray region, and then find how many times we have to add 300 to itself to add up to the area that's the total, okay? So what's the total area? We already calculated those here, right? The area of the ventilation structure and the area of the roof. So 7344, let me do that on my calculator, minus 25 times pi. That gives me 7265. 7265.46 feet squared. That's the area that we need to cover with roofing. So how many multiples of 300 will we need to get here? Well, I can list out all the numbers, but that's going to take a while. What I could just do is 300 times some number x is going to equal 7265.46. If I divide both sides by 300, effectively just divide this by 300, I end up getting 24.2. Okay, so is my answer 24? Is it 25? Is it 26? Which one is it? If we need 24.2 lifts, that means the 24th lift is going to be almost enough, but we still have, 0.2 of a lift worth of tiling that's left over. So we might be able to cover, all of this, but there's going to be like a little area like left over right at the end if we don't have the full amount. Okay, if we don't have that extra lift. So we're actually going to need 25 lifts. So your answer here is going to be C. Which of the following expressions equals a rational number when evaluated? So what's a rational number? It's a number that can be written as a fraction of whole numbers. Okay, so for example, 5 over 7, 2 over 3, 7 over 9,000, negative 3. Because really this is just negative 3 over 1, right? Those are all fractions of whole numbers. Examples that are not are, well, what I'll show you here. So this one is equal to square root of 18 because it's the same thing as square root of 3 times 6, which is square root of 18. You can combine the square roots like that. You can reduce this down to square root of 9 times 2, which is square root of 2 times square root of 9, which is 3 square root of 2, but still you have a square root in there, and that's not a whole number, so this is out. This one, if I expand it, we get 18i squared minus 9di plus 2i minus 10. This ends up equaling negative 18 minus 10 minus 88i, which is the same thing as negative 28 minus 88i. Since it has an I term in there, that means it is not a rational number. We cannot have imaginary numbers in our answer. Okay, so remember, fraction of whole numbers. This is key. Square root of 6 over square root of 2. Again, we can combine that to square root of 6 over 2, which is just square root of 3. But again, you can't simplify that any further, and it does not give you a whole number. This gives you 3 plus square root of 3. It's really close. You might be tempted to just say, oh, it's 4.5 or something, but that's not quite it. This cannot be written as a fraction of whole numbers. 4th root of 16, you can go on your calculator and type that in if you're really not sure. So 16 to the 1 over 4 gives you 2. and square root of 16 is 4, this can be written as 1 over 2, which is a fraction of whole numbers, so it's rational. Find the solutions for the following equation. So how do we solve something like this? The first step is to identify the absolute value brackets, okay? Once you've identified them, you want to find a way to isolate them, okay? So imagine the problem was 10 times this minus 5 equals 16. What you would do is you would add 5 on both sides, and you'd end up with 10 times 2x plus 3, absolute value equals 21. And then you divide both sides by 10, you end up getting absolute value of 2x plus 3 equals 2.1. And then what you could do is you could solve this. The first step is to isolate the brackets. In this case, we don't have to isolate with that second step. We just need one step, which is to add 5 on both sides, and then we end up here, and then we're good, okay? So at this point, what we have to do is we have to split this into two equations. The first equation is going to be basically this, but just without the absolute value brackets. Very easy, you can solve that. So that becomes 2x equals 18, x equals 9. The second equation is a little bit more complicated. You take that equation, you remove the brackets, but you replace them with parentheses and then put a negative on the outside, okay? And then you solve it for x, same type of deal. So you distribute the negative out, you end up getting negative 2x minus 3 equals 21. I can add 3 on both sides. Negative 2x equals 24. Divide by negative 2 on both sides. X equals negative 12. X equals negative 12, x equals 9. So A is your correct answer for 36. Moving on to number 37. The monthly costs of running a particular business can be described by the following function. If the number z is doubled from one month to the next and all the other variables remain the same, what's the change in c? Okay, so if I double z, there's a couple ways to do this. So you could just take this equation and then have another version where I substitute z with 2z, and then I'll have c2. Let's say this is c1. My new cost, c2, is going to be, the numerator is going to be the same, but the denominator is going to change from z squared to 2z all squared. 2z all squared is really just the same thing as saying 4z squared, right? And then what I could do to find the ratio, whether it's halved or quadrupled or doubled, I can divide c2 by c1. c2 by c1 is going to equal, since the numerators are the exact same, they'll just cancel out, okay? So so it'll just be really, let me actually write it out a bit. So if I take this and I divide it by, or if I, trying to think what's the best way to write this out. C2 divided by C1, let's do this. Copy, and then let's paste it here. So this is C1, and I'm going to divide C2 by all of this. Okay? C2 divided by C1, that's that right there. That's the same thing as doing C2 divide by 4z squared times essentially the reciprocal of this, because when you divide by a fraction, that's the same thing as multiplying by its reciprocal. So I can just multiply by z squared, and again this is all equal to c2 over c1 divided by 12,000 w squared x plus 2y squared. These two cancel out because they're the exact same. Z squared cancels out, so you're really just left with 1 over 4. So c2 over c1 is equal to 1 over 4. This is the key right here, okay? You have 1/4 your result. 37 should be A. Now that's one way to do it. The other way is to just plug in numbers and see what you get for this case, and then do the same thing by plugging in another set of numbers. So what are your set of numbers? Just set everything equal to 1. And then do another case where everything's equal to 1, except for z, which is equal to 2. Case 1, case 2. Okay, and compare your answers. So C1 is going to equal, when you plug in this, you'll get 12,000 plus 2 over 1, which is just going to be 12,002. C2 is going to be the same numerator. You're going to have 12,002, but then you're going to have in the denominator, you're going to have 2 squared, which is 4. Okay, so 12,002 over 4 versus 12,002. Again, it's just a factor of decreasing by a factor of 1/4. All right, we have this problem here for the next few. Johnson Metalworks manufactures stop signs for the city of Townsville. Each stop sign is an aluminum equilateral octagon of equal height and width, 24 inches, and thickness of 1/16 inch. A diagram is shown. What is the length in inches of each side of the octagon? So the length of each side, you might be tempted to think that it's just 24 divided by 3 because, there's 3 sides here. But the thing is, this length L is the same thing as this length L. But that's not the same thing as this height. This length L and this length L are not the same. Really, this is some height. This is some height as well. So these two dimensions are the same, but these two are different. If these were the same, right, L and H, then what would happen is you'd have an equilateral triangle, and your shape would look like, your shape with H's in it would look like this. And H clearly cannot go in that dimension because we don't have any measurements in that dimension. We need to measure relative to what's vertical and horizontal because we only have vertical and horizontal dimensions of 24, okay? So I'm going to create this new variable, H, and then we have L here, okay? Same thing down here. It's equilateral, so all the side lengths are the same. Let's move this L to the inside just so we have it a bit more clear. Okay, cool. So what is the length of each side? How can we calculate that? Well, I can create an equation. First of all, I want to solve for H. I can express H. I can't get the number, but I can express it in terms of L, knowing that this is actually a 45, 45, 90 triangle. How do I know it's 45, 45, 90? Well, because I made this vertical, horizontal, so this has to be 90 degrees. And then I said that it's an equilateral octagon, which means that all of these angles are equal. Sorry, they're not 45. They're all equal. If they're all equal, you can actually find the interior angle measures. So the interior angle measure of an 8-sided shape is going to be 180 times the number of sides divided minus 2, where n is equal to the number of sides, it's 8. So 180 times 6 is what? 180 times 6 is going to be 1080. Okay? That means that each of these is going to be 1080 divided by 8. 135. Okay, if this is 135, then what's left over here is 45 because this is a straight line. If I have 135 here, what's left here is just going to be 45 because 135 plus 45 is equal to 180. Okay, it's a bit of a confusing, dimension here, but that's the whole point. Okay, the whole key here is to make sure that we can identify these triangles as 45, 45, 90 triangles, okay? Now, let me just draw that one more time. So we have L, H, 45, 45. How can I express H in terms of L? If I express H in terms of L, I can keep in mind this ratio. 1 square root of 2. Or essentially, think of it this way. It's going to be x squared of 2, okay? So whatever this dimension x is, if I multiply by square root of 2, I get the hypotenuse. And if I know the hypotenuse and I divide by square root of 2, I get x. Okay? So my h is just going to be the hypotenuse, which is L, divided by square root of 2. All right? So this right here is just L over square root of 2, L over square root of 2, L over square root of 2, L over square root of 2. Okay? Now what can I see? I have this dimension, I have this dimension, I have this dimension. I can add those all up, sum them to 24, and there's only one unknown, which is L, in all of them. So I can solve for L. Let's do that. So L over square root of 2 plus 24, plus L over square root of 2 is equal to 24. I could say 2L over square root of 2 plus L is equal to 24. I can further simplify that. 2 divided by square root of 2 is just square root of 2. L square root of 2 plus L is equal to 24. Let's factor out an L. L times 1 plus square root of 2 is equal to 24. That means that L is equal to 24 divided by whatever 1 plus square root of 2 is. I can put that into my calculator. So 24 divided by 1 plus square root of 2. It's 9.94, which is close to 10. Okay, bit of a complicated problem. The key is identifying the isosceles right triangles. The aluminum metal that the stop sign is made of weighs approximately 0.1 pound per cubic inch. Which expression gives the weight W of the stop sign with area A pounds? So, using knowledge of prisms, really what the stop sign is an octagonal prism. It's an octagon shape that's extended in 3 dimensions by some value, and that value is 1/16 of an inch. So it's a really flat octagonal prism, okay? So what this is asking is, if we know the density, pound per cubic inch, so let me just write density. Usually use this Greek term rho, 0.1 pound per inches cubed. So the way you can calculate that is you can take your area and you can get volume. So if area equals some value that we don't know, the volume is just going to be area times 1/16, okay? So that's 1/16, or essentially area over 16, because they tell us, they tell us the area is just some letter A, and they tell us that last dimension is 1/16 of an inch, okay? So if we multiply an area by some dimension, then we'll get how essentially the volume of this prism shape. The volume of a prism can always be given. I'll redo this. Does this problem make sense? The aluminum metal that this stop sign is made of weighs approximately 0.1 pound per cubic inch. Which expression gives the weight W of the stop sign with area A in pounds? Okay, so we want to create an expression that relates area to the weight in pounds. Okay, so what do we know? We know this ratio here, 0.1 pounds per cubic inch, and we want to multiply this probably by something, and we want to get an answer that is in inches cubed. Sorry, pounds. We want something pounds, right? Weight is in pounds, so we want our answer in pounds. Okay, so how do we do this? In order to go from this to get pounds, we need to multiply by some volume, inches cubed. Okay, we need to multiply by the volume. So this weight is going to equal the density, rho. I'll just call it, it's a Greek letter, rho, density, times volume. And we need to calculate the volume essentially. So the volume, given the area A and this dimension of 1/16, we can get the volume. Because what is this shape really? It's an octagon, yes, but it's actually an octagonal prism. It's a really flat octagonal prism because it's only being extruded in that third dimension vertically by 1/16 of an inch. It's a very thin octagonal prism. Okay, the area of any prism is just the volume of any prism is just going to be the area of the prism face, call it face, times the height that's extruded. Okay, so for example, a hexagonal prism, it might look like this, right? It goes on, and the hexagon ends back here, right? So it's just whatever area of this face, you multiply that by the length it's extruded, and you'll get the volume. Okay, same thing applies here. So what's my area of the face? It just says it's A, but my length is given as 1/16. So I can calculate this as weight equals 0.1 pounds times area times 1/16. That comes out to area over 160. So 39 should be A. Moving on. Johnson Metal Works also manufactures smaller stop signs for bike lanes, and these smaller stop signs have a weight limit of 2 pounds. Given the same thickness and material, which of the following is the maximum area A for these stop signs in square inches? So the thing is, we can actually use this equation that we calculated here for this problem. So if the maximum weight is 2 pounds, we can just set W equal to 2, and then find what A is. Solve this for A. So you end up getting area has to equal 320 inches squared. 40 should be D. The following table is a frequency chart displaying how many car models fit within certain gas mileage ranges. How many vehicles have gas mileage between 30 and 40 miles per gallon? Okay, so we know that from 0 to 20, we have 15 cars. 0 to 30, we have 19 cars, which is essentially just plus 4, right? That tells us that in the 20 to 30 range, we added 4 cars. So in the 0 to 20 range, there might have been like 10 cars that had like 10 miles per gallon, 5 cars that had like, 15 miles per gallon, and then another 5 cars that might have 19 miles per gallon. But we added these 4 cars in after we went up to 30 because there were probably 4 cars that were around 25, 28, 22 miles per gallon, right? That's what that tells us. And then from here to here, we added 8 when we went from 30 to 40. That's what this question is asking about. In the 30 to 40 range, how many cars were there? So again, it's just the difference between these two ranges. This is the limit of 40. This is the limit of 30. You find the difference. You find that there's 8 cars in between those two ranges. Okay, so that's your answer there. A tank of water with length, width, and height, this, respectively, is half filled. An object is thrown in the tank, and 1 cubic foot of water splashes out of the tank, and the water in the tank rises a total of 2 feet after the whole process. What's the volume of the object in cubic feet? So imagine we have a rectangular tank. Let's draw a rectangle. Okay, it has some sort of depth, it has some sort of height, right? And it's filled with water. It says originally half filled. Okay, so let's just say this is 3, this is 6, this is 9. So the original volume of water is 3 times 6 times 4.5, right? Because it's half filled. The height is half. So 3 times 6 times 4.5 gives you 81. And that's feet cubed. Okay? Now, after we throw in this object, the water goes up 2 feet. Okay, so this is the increase. The red area is the increased area of the tank, the increased height. So your second volume, V2, is going to be it's going to be very similar. It's going to be 3 times 6 because we have the same height, length and width, sorry. But your height is going to change to 4.5 plus 2. And that goes up, if we put that in our calculator, 3 times 6 times 6.5, you end up getting 117, okay? Feet cubed. That's V2. Now, if we find the difference between these two, we can find essentially how much volume we added to the tank. 17 minus 81. So if we do 117 minus 81, you end up getting 36. Okay? 36 feet cubed. That's how much we added to the tank. So does that mean that the volume of the thing that we added, aka the object, is 36 feet cubed? Well, the thing is 1 cubic foot of water splashed out of the tank. So there's a whole bunch of water here. There's a whole bunch of water here that splashed out. And that water shouldn't have splashed out. If that water stayed in, you would have an additional 1 cubic foot of water in the tank. So your difference would have actually been 118 minus 81, and that would have meant you would have 37 feet cubed of that object. Okay, so really that object was 37 feet cubed. So we need to add that back to compensate for how much we lost. The graph of y equals x squared is in the standard coordinate plane. Which of the following translations are necessary to change the graph to this? So when we do translations up, right, down, and left, translations up or down are made to the entire function. So if I want to translate y equals x squared up 3, I would just add 3 to the equation. If I wanted to go right or left 3, though, that's where things get a little bit tricky. So right 3, or let me give you a general form. Right h units is where you change the actual x terms to reflect the change. So this equation would turn into y equals parentheses x minus h squared in order to move right h units. Okay? And if h is a negative number, then you move left. Okay? So it turns into essentially y equals x plus h squared. This is to move, again, right, or essentially left h units. Okay? Now, what if I want to go right and up? So what I would do is I would have to, the answer here I'll just tell you is we're going right, like I just said, because we're subtracting a number, and then we're going down. Okay, so in order to go right and down, I could do it in either sequence. I could go y equals x squared minus 1, and then go right to the 3 units, so y equals x minus 3 squared minus 1, or I could go y equals x squared minus 3, and then, x minus 3 squared, and then I could add in the minus 1 after. Right? So we're doing this, and we're doing this, 1 and 4. The 44th, the 4th and 8th term of a geometric sequence are 2 and 4. What is the 28th term in the sequence? Okay, so what we're going to do is we're going to plug these terms into the general form of the geometric sequence. Okay, this is the general form. I know that a of 4 is equal to 2, and a1 I don't know, but the common ratio I don't know either, and that's going to be to the power of what? N in this case is 4, so 4 minus 1. Okay, this is the first equation. A8 is going to be 4, and that's equal to a1 times r to the 8 minus 1. These are my two equations. If I divide one equation by the other, so let me just get rid of these. Let's divide the first equation by the second. Doing division, we get half equals, these cancel, r to the third over r to the 7th, or essentially r to the negative 4, okay? So half equals r to the negative 4 equals 1 over r to the 4th equals 1 half. That means r to the 4th equals 2. So r is going to be 2 to the 1 over 4, which if you do it on your calculator, to the 1 divided by 4, it gives you some decimal. You could just leave it as this form. It doesn't really matter, okay? R equals 2 to the 4th root of 2, okay? Now, I'm going to take all of that and reapply it to my equation, plug in r because I know it, find the 28th term because I want to find a of 28. I know r, I know n in this case, but I don't know a1. So I'm going to first, before I find a of 28, I need to plug in either one of these points into the equation and essentially solve it for a1. Okay, so a of n, let's just do a of 4 equals 2, and that has to equal a1 times 4th root of 2 all to the 4 minus 1, okay? 2 equals a1, 4th root of 2 all to the 3rd, which is the same thing essentially as a1, 2 to the 3 over 4. That means that a1 is equal to 2 over 2 to the 3 over 4, where this is 2 to the 1st. So 2 to the 1 minus 3 over 4 is the same thing as 2 to the 1 over 4. That's equal to a1. Okay? So a1 is actually equal to r in this case, which is kind of interesting. So we're going to take that into account, and then we're going to find, we're going to use this equation up here to get our a of 28. So the a of 28 equals 4th root of 2, 4th root of 2 again, to the 28th minus 1. In this case, that turns into 4th root of 2 times 4th root of 2 to the 27, which is just 4th root of 2 to the 28th, which is the same thing as 2 to the 1 over 4 to the 28th, which is the same thing as 2 to the 7th, which is 128. 44 is C. Okay, in order to add these, you need to find a least common denominator. So the way you can do that is by picking a common denominator. The easiest one is where you just multiply the two denominators together. So square root of 3 times square root of 8 equals square root of 3 times 8 equals square root of 24. Okay, that's going to be our common denominator. You can actually simplify that to be square root of 4 times 6, which is the same thing as square root of 4 times square root of 6, which is 2 square root of 6. Okay, that's our common denominator. Either one of these, it's the same thing. Okay, now in order to get a common denominator, I need to multiply this by a fraction. That fraction is going to be square root of 8 divided by square root of 8, and this one's going to be square root of 3 divided by square root of 3. Okay, so 8 square root of 8 over square root of 3 times square root of 8 plus 12 square root of 3 divided by square root of 3 square root of 8 equals something, and I need to find what that equals. 8 square root of 8 plus 12 square root of 3 over square root of 24. Okay, now that's close. We're getting closer and closer to the final answer. We've added everything together, but we don't see it in our answer option. So what are we doing wrong? The thing is, I need to simplify the denominator and the numerator by canceling out this, replacing this with this right here. Okay, so let's do that. Square root of 24 is actually 2 square root of 6. So I can also, and then the other thing is square root of 8 can be reduced to square root of 4 times square root of 2, which is 2 square root of 2. Okay, so let's adjust that as well. So 8 times 2 square root of 2 plus 12 square root of 3 over 2 square root of 6. The 2's cancel, this turns into a 6. So I can get this all to be 8 square root of 2 plus 6 square root of 3 over square root of 6. That's your final answer. 45 is A. In which of the quadrants of the xy coordinate plane does the graph of the following function exist? So this function is going to be at 3, 3. It's going to be centered, and it's going to be a circle with radius. R squared equals 10. If you do square root of 10 to the 0.5, you end up getting 3.16. So the radius is just a little bit bigger than 3. So your circle is going to look like that. Just a little bit beyond the origin. Okay, so what's going to happen is if it was exactly 3, this function would look like this. It would look like this, and this center point would be right in the middle. But this is just beyond a radius like that. So your function is actually going to go through just these 3 quadrants. And you can plug it into the graphing calculator and check which quadrants it goes through. It's going to go through 1, 2, and 4. 47. The determinant equals this. What must be the value of x for the determinant to have this value? So the determinant, again, like I said, AD minus BC. This is A, this is D, B, C, D. So A times D is x times x minus B times C, x times negative 14, has to equal negative 49. What I can do is I can combine these and move this to this side, and I'll get a quadratic. X squared plus 14x plus 49 equals 0. What are factors of 49 that equal 14? So 1 and 49, or 7 and 7. 7 and 7 obviously match up. X plus 7 times x plus 7 equals 0. If I set x plus 7 to be equal to 0, I get x equals negative 7. And if you're not sure, if you don't understand this procedure, what you can do is just take each of these answer options, plug them into the determinant formula, and just see what you get. And whichever one gives you this value, negative 49, that's correct. A large lot of real estate is approximately this much square feet. How many million square yards is this lot? Round to the nearest million. So we're just converting from square feet to square yards. One easy way to do this is to visualize. So imagine this is a square yard. I know that each yard has 3 feet. 1 foot, 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 1 foot. If I draw these like an array, I see that each foot squared fits in 9 times. So we get 9 feet squared in a whole yard squared. So I could just take this number and divide it by 9, okay? For every 9 square feet, there is 1 square yard. And you'll get this answer, I believe. So 250 million divided by 250 million divided by 9. You get 27. So actually, it's not going to be this number. It's going to be this number. I know that's the correct answer, but this is kind of a cheat way of doing it. Imagine you had units that you couldn't just visualize like this. Like if you were converting from miles to meters, for example. So how would you do that? Okay, so the way you do this is you have a formula. The formula is basically your desired unit equals a ratio of your desired unit to your original unit times the original unit. So in this case, this is 250. I'll just call it 250 feet squared. We're just going to leave it in we're going to forget the million, just whatever. Okay. The desired unit is something, some unknown number, yards squared. This is also yards squared. We need to calculate that number, and this is going to be feet squared, okay? So we need to find, in order to use this equation properly, we need to know this side of the equation in its entirety. We already know this term, but we don't know the ratio of desired to original. What's the ratio of yards squared to feet squared? Now, I already told you that 1 yard squared corresponds to 9 feet squared, but imagine you don't know that. How can you get that ratio? So what you can do is you can actually use just the ratio of 1 yard to feet, 3 feet, right? And multiply this by 250 feet squared. But the thing is, these units aren't the same. They have to be the same in order for this to cancel out and for you to get a final unit of yards squared. Also, this isn't yards squared, this is yards. So something is wrong. We need to have this actually add up by canceling out. So what can we do? Well, you can take your ratio of just 1 yard and 3 feet and square the entire ratio, and this actually turns into 1 over 9. Yards squared per foot squared. Okay? You don't have to write it out like that. All you have to do is take the ratio and square it. It's this simple, okay? And this will give you an answer of 28 something approximately yards squared. Okay? It's as simple as that. For which interval is cosine theta greater than half and sine theta greater than half? So we can use the unit circle and check all of the values. I'm just going to plot the values of cosine theta and sine theta. So this is 1, 0. Remember, it's x is cosine, y is sine. This is going to be 0, 1. This is negative 1, 0, 0, negative 1. So we want to find where are they both greater than half. So here, we remember ASTC. Essentially, this acronym ASTC tells us at which parts of the unit circle are each of the trigonometric functions positive or negative. So in the A quadrant, all 3 of them, sine, cosine, tangent, are positive. Here, only sine is positive. Here, only tan. Here, only cosine. So it wouldn't make sense for our answer to be in any of these because obviously it is not going to be the same sign here. So that doesn't make sense. You're going to have to be somewhere here. And all the answer options, except for this one, are only in this quadrant. So that's already done for us. The answer can't be B because it's saying everything from 0 to pi over 2 is going to be greater than half. But clearly, even very close to pi over 2, we're getting very close to some values bringing it 0. So that doesn't make sense. We can't have that be the correct answer. Pi over 4 to pi over 2, again, we can't get close to pi over 2 because what do we notice near pi over 2? Cosine approaches 0. So that doesn't make sense. Pi over 6 to pi over 3. So what's pi over 6? Pi over 6, if you do this, it gives you a value of, I believe, square root of 3 over 2 and half. So they're both half or greater. Square root of 3 over 2 is greater than half. Pi over 3 gives you the same thing. It's actually half square root of 3 over 2. So actually in this region between here, the criteria is met. So that's the correct answer. What about this one? Pi over 2 is less than theta is less than pi over 3. I think this is a typo. This is actually supposed to be pi over 3, pi over 2. Regardless, it's just saying this region right here. And this region does not work because, again, like I said, as you get very close to here, once you go past this, your sine value becomes, your cosine value becomes less than half. The cosine is this horizontal dimension right here between this point and the origin. As you get closer this way, your cosine dimension becomes a little too small, okay? Another way you can interpret this problem is if I give you a unit circle, you're looking for, and since we know that x corresponds to the cosine, y corresponds to the sine, you're essentially looking for, if you're looking for where they're both greater than half, you're looking for where are x and y coordinates all greater than half. So if I plot half here and half here, you're essentially looking at this limited region, and you're looking for the angle measures at those regions, and they correspond to pi over 6 and pi over 3. Okay, that's another way to interpret this problem. Our triangle prism with its dimensions is shown below. What percent of this triangular prism's surface area consists of the combined areas of the two equilateral triangles? So we need to find the area of the two equilateral triangles and the area of these rectangular faces. So if we know that they're equilateral triangles, then all of these triangular sides should be 6, which means that this rectangle is just a 9 by 6, and we have 3 of them. So the area of rectangles is equal to 9 times 6 times 3, which is 54 times 3. 162, and the area of the triangles, let's just calculate one of them. So it's going to be half base times height, or you can do it this way. It's going to be half AB sine of C. Since we know it's a equilateral triangle, the C degree measure is going to be 60 degrees. A and B are just going to be your side lengths, so they're both going to be 6. So you can calculate this. You'll end up getting, do it on my calculator, 0.5 times A, 6 times sine. Let's plug in sine of 60. I think that's radians, so let me do that again. 0.5 times 6 times sine of pi divided by 3. Let's see what this gives me. This gives me 15.58. Okay, and we have 3 of those, so we're going to do area of all triangles equals 15.58 times 3, 46.76. Okay, so the total area total is equal to 46 plus 162, that's 208. So if I divide this by this, 46 divided by 208, I get 22%. And that is, oh, hold on. I don't have 3 triangles, I have 2. So this number is actually incorrect. So we need to do 15.58 times 2, 31.16. So if I did, and this is going to be different. This is going to be 208 minus 15.58. That's 192. So if I do this divided by this, 31 divided by 192, I get 16%. That's the correct answer. Given the following equations, if the second equation is adjusted to have a slope that's perpendicular to the first, what's the x-intercept of the second equation? So what's the slope of the first? Let's turn this into y equals mx plus b form by isolating y. So first move the 5x to the other side. 4y equals negative 5x plus 12, and then divide both sides by 4. Y equals negative 5 over 4x plus 3. Now we're asked a perpendicular slope to the first. Okay, so what's the slope of the first? It's just this m value, because it's y equals mx plus b form when y is isolated. So this m equals negative 5 over 4. In order for two lines to have a perpendicular slope, the slopes must be negative reciprocals of one another. A negative reciprocal is where you take the original number, you reverse the sign, so it goes from negative 5 over 4. We make it a negative version of that, and then we reciprocal it by flipping the numerator and denominator. Okay, so it would have a slope of this. So we need to take this line and change its slope to this. What's the original slope? What's the original line here? Let's first subtract 6x on both sides. Negative 8y equals negative 6x plus 10. And then divide everything by negative 8. Y equals 3 over 4x minus 5 over 4. Okay, this is your second line. Now what we need to do is change this line to have a different slope. So the slope is now going to be y equals 4 over 5x minus 5 over 4. And now it's asking us what's the x-intercept of the second equation. The x-intercept is a point when we're at a certain x value and the y value is 0. Okay, so let's plug in 0, 4 over 5x minus 5 over 4. Move the 5 over 4 to the other side. 4 over 5x equals 5 over 4. Multiply both sides by 5 over 4, which is, again, like I said, the reciprocal. We know that when you multiply two fractions together and the two fractions are reciprocals of one another, the fractions cancel out. So x is going to equal 25 over 16. 51 should be D. Moving on to 52. Josephine plays a game where she rolls a 6-sided dice and gets points for the corresponding outcome. A roll of 1 results in 1 point, and so on. What is the expected number of points she should have after 90 rolls of the dice? So you have to think, for a very large number of rolls, what's the average that you would expect? Well, if I roll 6 times, I would expect to get a 1, a 2, a 3, a 4, a 5, and a 6, right? If I take the average of all of these, the average is just equal to the sum divided by 6, or essentially the number of values. So that's going to be whatever 6 plus 5 plus 4 plus 3 plus 2 plus 1 is, 21, divided by 6. 7 over 2, which is 3.5. Okay? You expect this on any given roll. Now we need to multiply this by 90. 90 times 3.5 is 315. So that's your answer. If you roll 90 times, you should get a sum of 315. Theoretically, how many times would she have to roll to earn 450? Okay, so based on this problem, we know that the average roll is 3.5 per roll. So let me just write it like this. Points per roll. Okay? Now, if I want to earn 450 points, I need to find how many rolls. I can just divide 450 by 3.5 because I know I'm getting each roll to be 3.5. So 450 points per roll divided by, 450 points divided by 3.5 points per roll. I end up getting 450 divided by 128.57. Okay. So we end up in this weird scenario, like, is it 128 or 129? Obviously, we could just round up. And I believe rounding up does get us the right answer. But conceptually, what does this mean? If you roll 128 times, and you'll notice that that is less than the required value. So 128 times 3.5 is 448. Okay? This is not the same thing as 450. If we want at least 450 points, we have to do another roll, which means we have to add this to, make it 3.5. Sorry, 129, and that means we would be at 451.5 or something like that. Okay? That's how you do this particular problem. The discriminants of 5 equations are shown below. Which of the equations have 2 distinct real solutions? Okay, 2 distinct real. That's the condition. Okay, so if we look at each one, we notice some are positive, some are negative, and then we also have 0 here. So when you have a discriminant of 0, if you remember the quadratic equations, the quadratic formula skill video on our website, this means you get one solution. Right? So for example, if you do the quadratic formula, and this entire thing, and the b squared minus 4ac part, the discriminant is 0, that means that this basically goes away, and your only x-intercept is just negative b over 2a, right? That means you get one solution, and it's just whatever that value is. So 2 distinct real solutions, what does that mean? That means that this number is non-zero, and that you actually have a square root, a positive square root, and a negative square root that you get out of this. Okay? That's 2 solutions. They're distinct. Now, what happens in the case where this is negative? So if the b squared minus 4ac is negative, like in this case, that means that you're getting imaginary solutions, because you're going to end up taking a square root of like a negative number, and you're going to have like a 2i or an I something in there, okay? So we cannot have a negative. This cannot be negative, which means 2 is out. Any answer option with 2 is incorrect. And notice how none of the answer options have 2. Wow. Okay. So like I said, we essentially need this to be a positive number, and any positive number applies, and it gives us 2 distinct real solutions. So your answer is going to be 1, 3, and 4. 54 is C. How many distinct real positive integer solutions does the following equation have? So again, distinct real positive integers. Okay, so let's just first find all the solutions, and then we can narrow it down after. So this gives us a solution of x equals 0. This gives us a solution of x equals 3, but it's repeated. So I'll just write it again. X equals 3, x equals 3. Same thing here. This gives us x equals plus or minus square root of 5 because it's a difference of squares. where b squared equals 5, a squared equals x squared. That means that a is equal to x and b is equal to square root of 5. Okay? And in this form, if you do this and set this equal to 0, you'll get two solutions, x equals plus or minus square root of 5. Here we get no solutions. This is these are imaginary. And here we get x equals -3, x equals -3. We get it twice. Okay? So distinct real positive integers. So what can we narrow down? Integers, these are not integers, so these are out. Positive, these are negative. Real, these are both real. Distinct, so we have 4 solutions here, but 2 of them repeat and then 2 of them repeat. So if you just pick one, we get essentially 2 as our answer. 55 is 2. So we have all these solutions, essentially 7 different solutions, 7 points, but only 2 of them are distinct real positive integers. Actually, there's 8 solutions, but only 2 of them are distinct real positive. 55 is B. Two ships are at sea exactly 100 kilometers apart. The 2 ships are also 175 kilometers away from the same lighthouse. What's the distance between the lighthouse and the midpoint of the 2 ships? So let's just draw this up. We have 2 ships here and here. Then we have a lighthouse that is 175 away from both of the ships. So let's label that. We have ship, lighthouse. 175, 175, 100. Okay. We're asked what's the distance between the lighthouse and the midpoint of the 2 ships. This is the midpoint. So how can we solve for this distance right here? You can do it with Pythagorean theorem. Clearly the answer options don't want you to do that. They want you to use sine, cosine, tangent. So what we'll do is we'll use sine, cosine, tangent. So I'm going to try to make a triangle here. In order to get this triangle made, we need to know, we already know the hypotenuse. We kind of know this side and we need to find this side, okay? So in order to do that again, like I said, we need to know this side down here. I know that that's 100, but this side specifically will be 50. It'll just be half of that because this is a midpoint, right? It's half. This is going to be 175. So we have that as well. In order to do this, I'm going to label an angle here that is theta. And let's call that, this is going to be our theta. And this is going to allow us to create a sine ratio opposite over hypotenuse, okay? So sine of theta equals 50 over 175. That means theta equals sine inverse of 50 over 175. You can calculate that. You don't really need to. The actual value doesn't matter. Okay. Now, if I do cosine of this angle, what is that? That's relating the adjacent side to the hypotenuse. So cosine of theta equals adjacent, which I'll label x, that's what we're looking for, over 175, the hypotenuse, which means x, which is the side we're looking for, equals 175 cosine of theta. And we know theta, because we have it written in numerical form here, 175 cosine of sine inverse of 50 over 175. Okay, and there we go. That is that right there. A function f of x is considered even if f of x equals f of negative x. Which of the following is an even function? So f of x equals f of negative x. For example, just to visualize, that means that if I took the function and I flipped it across the y-axis, the function would look the exact same. So for example, y equals x to any even exponent, y equals x to the second or y equals x to the fourth. These are all even functions because they're symmetric about the y-axis. Okay, that's really what an even function means. What this means, and that's what this is saying right here. If I flip my x values, where all the x values flip around here, essentially reflecting across the y-axis from x to negative x, the graph looks the exact same. It looks the exact same. That's why it's equal. Okay, so you can check that for all of these. For example, if f of x equals sine of x, and you want to check does f of negative x equal sine of x, just plug in a value for x and see what happens. So let's say x equals 3. Does does sine of 3 equal sine of negative 3? It should not, which means that this is not even. Cosine, it will work. cosine of 3 equals cosine of negative 3. F of x equals this. You can try the same thing. Plug in a number, plug in a number, plug in a number. You'll find that these don't work. So B is your answer here. Two functions have the following forms. The maximum value of m of f is double that of g. The frequency f of f is double that of g. Which of the following is true? Note that c equals s equals 0, so we can cancel those out. So the maximum value of this is double this one. The frequency of f, which is related to this, is double that of g. Now, what do we know about frequency? So we know period equals 2 pi over b, where b is this number in front of the x, 2 pi over b or 2 pi over r. Frequency is just the inverse of period. So frequency equals 1 over period, which is just b over 2 pi, r over 2 pi. Now, we know frequency is double. So if frequency essentially increases with this number. So if we know that this number b is higher, or r is higher for one of the other graphs, that means the frequency is going to be higher. It tells us the frequency of f is double that of g, which means that this b value is going to be 2 times the r value, okay? Since this maximum value, m, is double that of g, that means that a should be equal to 2 times q, okay? Again, these graphs, the reason we can compare the maximum value is because these two graphs, one is a sine, the other is cosine. So sine graph will look like this, cosine graph will look like this. They're both centered on the x-axis. This is like the middle value vertically of both of these graphs, okay? Since they're centered like this, we can compare the maximum values and the minimum values, and they'll show the same relationship of double or triple if one is higher than the other, okay? So that's how that works, all right? B equals 2r and a equals 2q. This is out, this is out. The answer for this, we can also check D and E. So if we check D and E, let's see what we get. So the period of f is double that of g. Well, so the period of f is what? 2 pi over b. So this is going to be small, this is going to be larger, because we know b is greater than r, right? B is double r. So if b is greater than r, that means that this is less than this. The period of f is half of g. The period of g is quadruple that of f. This is not a factor of 4, this is rather a factor of 2, so 4 has nothing to do with this. Jasmine is taking a 5-question multiple choice quiz. Each question has 4 answer options. What's the probability she answers none of the questions correctly? Okay, so the probability of getting a question right is 1 out of 4. Probability of getting it wrong is 3 out of 4. So if you want to find the probability of getting 10 questions wrong, it's effectively the same as the probability of getting 1 question wrong times itself 10 times over. So it's just that probability to the 10th power. Okay? So you're going to raise the probability to the 10th power. This is what you do when you have a single probability and you want to find the probability of that event happening multiple times. Okay? So the probability of getting something wrong, 3 over 4. We're going to raise that to the 10th. Okay? And if you do that on your calculator, you'll get a value that is close to 0.056. Sorry, this is not to the 10th. This is to the 5th. There's 5 questions, not 10. Okay, so 5. 0.75 to the 5th. So it's 0.237. There's a 23.7% chance that you're going to get any given question wrong, or all 5 of these questions wrong on your test, okay? Which is corresponding to answer option A. Given the equation, if the period is doubled, which of the following is the resulting equation? So period is equal to 2 pi over b. I discussed period a little bit in defining it in this problem up here. So I'd recommend you check that problem out as well if you got this one wrong. The period is given. So if we double the period, that means we are taking b and halving it, right? Because the relationship here is, as this doubles, this halves. And if this is doubling, that means this has to be cut in half. This has to get smaller for this to get bigger. Okay, so if the period is doubled, the b value, which is effectively the number in front of the x, the coefficient in front of the x, has to decrease by half. Originally it's 4, so it would turn into 2. All those other options are wrong. That's the end of this exam.